Hello. In 153 today, we are looking at 11.5 probability with the fundamental counting principle, permutations, and combinations. So what we're doing in 11.5 is taking everything that we've done in the previous sections and putting them all into one problem. What I'll do, some of these problems or examples are a little bit longer than the others. I recommend you to pause the video, read through them on your own, and then restart the video again, because I'm not going to read through everything to you. We have two main objectives today, is to compute the probabilities with permutations and then compute them with combinations. So for the first one, we're going back from 11.2 to those 6 jokes about books that we talked about. And we're saying if each joke is written on a card and put into a hat, then drawn one at a time, we want to look at how many different possibilities can we pick the order of these jokes. So now we want to find what is the probability that a man's joke will be delivered first and a man's joke will be delivered last. Anytime, one thing I want you to really look for in your problems, if it's asking for a probability, that means you have to set up some kind of fraction in your problem. If it's just asking for number of ways, then you can just use combinations, permutations, or the fundamental counting principle. But when we're talking about a probability, we need to set up the fraction just like we did the previous section and of whatever it's asking. They want to find the probability that a man's joke will be first and a man's joke will be last. Well, first thing, when we look at all the people in the problem set, we'll know that altogether there are 5 men and that there is only 1 woman. Altogether, we have 6 people total. And you can see that this one's kind of set up for us. So we want to find the probability of the man's joke first and a man's joke last. So we need to take the number of permutations with a man's joke first and the man's joke last and divide it by the total number. And that goes back to what we did in 11.4 by just taking the number of possible outcomes divided by the total number of outcomes. So we want to approach these problems as 2 separate problems, the numerator and the denominator, and then put them together. And some of the problems you might see, they'll have it broke up for you, but we're going to work through it all together. So we're going to start with the numerator first. So we want to find with a man's joke first and last. Well, we know that there's 6 people altogether. So there's the first joke, the second joke, the third joke, the fourth joke, the fifth joke, and the sixth joke. Well, if we want a man's joke to be first, that means we have 5 possible choices of what's going to go first. And then we also want to know that there has to be a man's joke last. So we want to address this one and this one first and then fill in with the rest. So you have 5 to choose from for the first joke. Let's say we choose one of them. Now we only have 4 left for that last joke. Well, oops, sorry about that. If we have so 6 people altogether, there we used 2, now we have 4 people left, and that's what we're going to fill in here. So then 4, 3, 2, 1. Now we can use the fundamental counting principle and multiply all these numbers together, and this is where you should have a calculator handy, and when you do that, you multiply them, you get 480 different ways that you could tell what the man's joke first and man's joke last. However, we want to find the probability of that happening. So now we need to address the denominator. So we want to find the total number of ways 6 jokes can be delivered. So, okay, if we do the same thing, the first, the second, the third, the fourth, the fifth, and the sixth. Now this time we're not concerned with where the man's joke lies. So we just want to take their 6 times 5 times 4 times 3 times 2 times 1. And again, using your calculator, you multiply that there's 720 different ways to tell those 6 jokes in any order. So now to find the probability of this, we need to use these 2 numbers here to create our fraction. Again, we said this is going to be the numerator and this is going to be the denominator. So we set up 480 divided by 720. Now we said we always want to reduce our fractions completely. This reduces to 2/3. Next example. Go ahead and pause the video and I want you to read through this problem. And this problem works with winning the lottery. So go ahead, pause the video, and read through this. Okay, so after reading through it, you will notice that we want to find the probability what is the probability of winning the jackpot. So that's our goal here, is to win the jackpot. And in order to win the jackpot, you have to choose two different balls. You have to choose what are we looking at here? A white ball and a red ball. And you have to get them correct. So the first thing, we want to find the probability of winning the jackpot. So the number of ways of winning the jackpot. So let's talk about this numerator first. So the numerator, well, in order to win the jackpot, there is only one certain way that you can win the jackpot. You have to have the 5 correct white balls and the 1 correct red ball. So the numerator, there is actually only one way to win this because there's no other possibilities. Now we want to talk about the denominator. Here's where we have to do a couple things. There's two different things that we're looking at. One, you have to choose 5 white balls that are numbered 1 through 59. So that's the first thing we have to do. So we have to choose 5 from 1 through 59. The other thing is you choose, I'll use purple here just so we can see the difference here. You have to then choose 1 red numbered 1 through 35. So now we have to choose 1 from 1 through 35. So now we need to compute both of those. And since the order does not matter here, we're going to use the combination. So we have 59 choose 5, and then we also have 35 choose 1. And just like we've set up problems in the past, anytime you have two things like this is where you have to use the fundamental counting principle. So what I'm going to do here, you could compute them separately, but I'm just going to set up the fraction. So the numerator, we know that there's only one way to choose the winning jackpot, and we have to divide that by 59 choose 5 and multiply that by 35 choose 1. And when you get that, again, this is where you should be using your calculator. You can type all that in, and you get 175,223,510. So you have one chance out of over 175 million is the probability of winning the jackpot. Okay, we have one more example that we're looking at, but we're going to break this one into 2 parts. So now we're going to be looking at probability and combinations again. So here we have a club consisting of 5 men and 7 women. 3 members are selected at random to attend a conference. Find the probability that the group consists of 3 men, and then we're also going to find the probability that the group consists of 1 man and 2 women. So the first we're going to look at is the probability of selecting all 3 men. So again, we want to start with the numerator and denominator as 2 separate things. So for the numerator here, we want to find the number of ways of selecting 3 men. Well, we know altogether there were 5 men to start with. So our numerator here is going to be 5 choose 3. And again, we're using 5 because that was the total number of men. Now we have to look at our denominator. The denominator now is the total number of possible combinations. Well, if we have 5 men and 7 women, altogether we have a total of 12 people. So out of that 12 people, we have to choose 3 of them. So again, this 12 represents the total number of people altogether. So now to compute the probability of selecting 3 men, we want to take this 5 choose 3 and divide it by 12 choose 3. Again, you could compute these separately. If you were to compute them separately, you see that 5 choose 3 would give us 10. 12 choose 3 would give us 220. When you simplify that, you'd get a probability of 1 at 22nd. Now, we want to go on to part B. So now we have to compute the probability of 1 man and 2 women being selected for this committee. So now the numerator, we have to take two things into account because now we're talking about men and women, whereas in part A, we were just looking at the men. So starting with, it doesn't matter which one, let's start with the choosing 1 man. We want to choose 1 man from, and we know that there were 5 altogether. So 5 men, and we're choosing one of them. And then we have to choose 2 women from 7. So that would be 7, choose 2. So here's going to be the 2 different ways that we need to look at the numerator. And then you can see that 1 plus 2 does give us the 3 that we're selecting because it says 3 members. If this is asking for 3 members, your numerator, what you're choosing, should add up to 3. Now the denominator here is going to be the same as the top part. Denominator is the same as part A because you're still choosing 3 people from a group of 12 altogether. So now we have to set this up as the numerator is going to be 5 choose 1 times 7 choose 2, and we're dividing it by that 12 choose 3. You can work out that, or you can use your calculators. In the end, after a reduced fraction, you should get 21/44. That is all that we have for 11.4. You'll notice on your notes that you do have some practice problems out of your textbook. You're more than welcome to work through those. I will not be collecting those, but they are great practice. Hope this video was helpful for you, and please reach out if you have any questions. Thank you and have a great day.